There we go. All right. Well, let's see. Short week for us, I guess, 3 days. And a couple things to mention. I did mentioned it maybe in our forum, change some due dates just based on our pace, you know, how things are going. So check that calendar in My Open Math. In particular, I already sort of adjusted a couple test dates. If you were really looking through that calendar, you might notice that. So I'll probably submit or turn in an updated schedule on the syllabus if you are actually referring to our lesson schedule in the syllabus, just because I've kind of bumped things a day, you know, put it off a day. Just make sure we have time. Things like just reply, you know, somebody else texted me this morning or messaged me, homework, hand-in homework, and the discussion forum grades are grades I have to go in and enter myself or just say, yep, credit, credit, credit. So if they look like 0, don't panic. I just have to get in there, probably do that later today and enter those grades myself. So just a little bit of business there. I did also mention, that's right, you know, homework 1.3, 1.4, looks like most of you are through that. That's great. It's due this evening, you know, by the end of the day. I had offered to, you know, hold another Zoom meeting, just, you know, be available. Really only kind of got one person, I think, that expressed real interest in that. You know, unless I hear from a whole bunch of you later today, I think I'm gonna just hang out like I usually do. I'm always checking messages and my email, looking for questions from you. I don't think I'm gonna just hold a separate Zoom meeting unless I get a whole bunch of interest, you know, later today to do that tonight to get your homework done on time. But you know, down the road, that's an option. We can work in an extra session sometimes if there's enough interest. All right. So send me messages, you know, or post on the forum, and if you have things to add as far as that goes. Okay. So with that in mind, here we go. Get started. We need to finish up our 1.5 section, which was multiplying and dividing fractions, and we'll get into adding and subtracting today. Get myself here situated. All right. So we were pretty much, you know, done with strictly multiplying at the end of the last class, and you know, we got to sort of, that relates to dividing. We have to get into that. Let me get up something.
I did have a quick question when it came to multiplying fractions. There was a very difficult question in the book,
okay,
and I was hoping to do just this one problem. It was in parentheses, a negative 63 over 84.
Okay.
And next to it in parentheses is negative 44 over 90.
90.
When it just comes to the bigger numbers is where my confusion comes in. So if you could explain how to maybe simplify something like this.
I got those right?
Yes.
Okay, so sure, this is an example of one with big numbers, and I would really encourage you, as we discussed last time, to try to look for common factors that you can cancel either within each fraction or even between top and bottom, numerator and denominator, you might say across those two fractions, okay? So here comes your math facts. You know, how comfortable are you with recognizing things that you might be able to divide both of those values by? When I look at these two, you know, if you remember our divisibility tests, are they even? Can you divide by 5s or 10s? Or 3s is that one where if I can add the digits and it comes to a multiple of 3, I know I can divide that by 3. Well, 63, probably pretty obvious. You can divide that by 3. 84, maybe less so, but 8 plus 4 is 12. So I ought to be able to divide 84 by 3 also. So I'm going to start that way. I'm just going to try to make those numbers smaller before I actually multiply. If I multiplied straight across, I get really huge numbers, and it gets really, well, it's just harder to start simplifying. So if I divide this by 3, I'm going to get 21. Well, I divide this by 3. Let's see. That's 2 and 8. 28. 3 times 28. And you can do that on the side, scratch work, whatever. You know, I'm a little more fluent in it, you might say. And so there, I made them smaller already. Oh, but now I look at those two numbers. Do you see a common factor? I could do it again. They're
Yes.
both divisible by 7s.
Mhm.
I divide this by 7 and this by 7. That whole number was equivalent to 3/4. 3/4. And I know some of us like that. Just rewrite it. Get rid of all the mess. And notice don't lose your negatives down. Excuse me. Now this one, top of my head, I'm just going to say maybe it's even. All right, they're both even. So divide by 2, I get to 22. Here I get 45. Cut him in half, right? Now let's see. 22 is 2 times 11, 2 prime numbers. And this is 5 times 9, no common factors. I'm done with that one just by itself. So, all right. Hope I'm doing what you're asking me to do here. But anyway, that was within those 2 fractions. I just made them reduced. I can now try to, well, what about between the fractions? I can divide both of those by 3s, right? If I divide this by 3, it leaves a 1. This is 3 times 15. These are both even. If I divide them by 2, I get 2 and 11. And just to rewrite, that means a negative 1/2 and a negative 11/15. And just one more look to see if there's anything else I can do. I don't think so. Now I'm finally ready to multiply. Now negative times negative means we'll get a positive result. 1 times 11, 2 times 15. Ta-da. So it was a bunch of simplification work, I think was the point there. Let's let somebody else in. Here we go. Okay, hope that helps.
Yes, thank you.
Right. All right. Hello.
Yes, it helped. Thank you very much.
And in there. Okay, so I'm going to erase this. All right, here we go. And I wanted to do one multiplication specifically. Let's see if I can make up I should do this, make up a good one here. 2/3 times 5/8 times 9/16. Now here's 3 fractions in a row that are being multiplied together. And it was just multiply, multiply, multiply. So I could do 2 times 5 times 9 and get a big number on top and similarly on the bottom. But I'm going to look for some things to cancel. Now, let's see. In particular, I noticed, okay, I could divide both those by 2. And now I don't see anything else, no more evens that I could cancel. But the point here I want to make is, oh, this 3 I could cancel all the way over with the 9, right? I could just kind of really rearrange those multiplied numbers if I wanted to. But I could divide this one by 3 and way over here, that one also. So that was the point of this example, to show that it didn't just have to be the one next to it. As long as they're multiplied together in a row, one here and one way down the list, as long as there are a bunch of things multiplied, you can cancel those common factors. And that was all. So now what do I get? 3 times 15, 5 is 15, and 1,
You
4.
can't do the 4 and the 16.
64, yes. Okay.
Can you reduce the 4 and 16?
Oh, now these are both in the denominator.
Oh, okay, that's right.
Right, 4 times 16.
Thank you.
Don't cancel anything within the same
That's
sum.
right.
All right, so that was the point of that one. All right. All right, so division of fractions. I'm going to make up something to sort of explain why we do division the way we do. I'm going to say 3/4. I'm going to make a funny looking fraction. All right. we're going to deal a little more with these a little later, but this is what you call a complex fraction. Complicated, right? Complex fraction is a fraction that has fractions inside of the fraction, right? Fraction with the top is a fraction, the denominator is a fraction. All right, so gee, I want to simplify this and make it look like at least one simple fraction. I'm going to build an equivalent fraction. Now think of it like one big fraction, like 4/5. As long as I multiply the same thing top and bottom, I've built an equivalent fraction. You know, 8/10 means the same value. Well, I'm going to pick a very special number to multiply the top and the bottom by. It's going to be what we call the reciprocal, flip over, the reciprocal of this fraction. Maybe you can see what's going to happen there already. I'm going to multiply both the top and the bottom. Now this is just explanation at this point, okay? Watch me wave my hands, huh? I'm going to multiply the top and the bottom by the same thing. So whatever I get is going to be equivalent to what I started with. But I chose this so that the 8s cancel and the 5 cancels. Now I've got a 1 on the bottom. And so now I'm going to leave this. This is equivalent to this complex fraction I started with. And because it's got a 1 on it, I'd probably drop the 1 and say that's the same as these two multiplied together. We just did a bunch of multiplication. We know how to do that now. But notice now, I started with this, right? And one way to think of that is 3/4 divided by 5/8, right? And what did I turn it into? Flip over the second fraction and turn it into multiplication. It's called, the phrase you might have heard, invert and multiply. You invert the one after division symbol and turn it into multiply. So we never directly divide fraction by fraction. We turn it into multiplication. And this is sort of the justification why it works. Because I can actually show that this turns into the same thing as 3/4 times 8/5. All right, so we turn division into multiplication always with fractions. Now here I would, just to finish this up, right? Simplify, I'd probably divide both of these by 4s. Looks like I get 6/5 would be the final simplified version of that original fraction. So that's a long story to say division, we turn into multiplication. Got to get somebody else in here. All right, good. All right, so that's my start, my setup for division. Yeah. Looking at my notes. Yeah. So anytime probably use same old easy numbers here. Anytime I start with one fraction divided by another fraction, it's equivalent to, when we flip a number over, we call it its reciprocal. Multiply by its reciprocal. Make sure it's always the one immediately after the division symbol that gets flipped over, the second one. Sometimes you might have 3 in a row and multiply, divide, multiply. It's always just the one after the division symbol. So now I would multiply, nothing to cancel. I just made this up, 16/15. Right? That's how we basically deal with division. And let's see. I know I make it look so easy, right? Even if there's like a variable in there, right? We're going to see variables all different places now. This is just one fraction divided by another fraction, happens to have a variable in it. So I'm going to turn it into a multiplication problem by saying that's 7 over x, multiply by 7 over x. That sort of assumes the x can't be a 0. If you recall, we can't divide by a 0, but now I just have, this is negative times positive, so I'm going to get negative 28, and that's just 5 times x. I'd say 5x. That's all I can do with that denominator. Let my kitty out the door here. Now she take me out. She wants to sit by the sunny door. Okay. All right, here we go. Keep moving. And let's see. Oh, I like to do something like this. Just another one, right? I did this one in particular, though, to point out, oh, you might look at that and say, oh, they're fucking divide both those by 9s. That's only, you can't do that until it's a multiplication problem. You can't do that right now, divide those both by 9s, until it's multiply, and then you're canceling a common factor between the top and bottom of a multiplication. So first thing, I just got to turn it over. Okay, got it. Now I can look to see if there's anything to cancel. Oh, I can still do some 3s in here, right? Divide by 3, divide by 3. A little bit simplified, huh? 35 over 81. If I do my canceling now, that should be lowest terms, but it's always good to check. See, is there maybe something else I could have canceled? But I don't think so.
Well, I have a quick question while we're on this topic.
Yes.
One thing I was discovering was that at times there were multiple numbers that you could reduce by. For example, in the practice, there was 4 times 3
Hang on.
over. Sorry.
Like, okay, 4 times 3.
Over
Yeah.
6 times 6.
Over 6.
Over 6 times 6.
6 times 6. Yes.
And I got 12 over 36.
Yes.
Which I could reduce by 3 or 4, basically, which inevitably leads me to the same answer either way. But what is the best way to choose the number that you go to reduce by?
I would say it really comes down to what do you recognize that you can divide them by.
So there's no wrong answer.
Yeah, right. As long as you keep going, I did it once and now I see I can do it again by something else.
Okay.
Right now, you can divide both of those by 12. So I'd say the best answer is the biggest number you can think of that you can divide them both by.
Okay.
Both divisible by 12. But like you said, if I did by 3s, oh, and now I can do it by 4s. Or I could have done it the other way around.
Yes.
1/3.
Either way, 1/3. Okay, wonderful. Thank you.
No rule. We got to do it one way or the other. It's really. What do you see? What do you recognize? Okay.
Can we do a division problem?
A division.
It's 13 divided by 8/3.
Divided by 6/3.
8.
Oh, I'm sorry, 8/3.
Sorry.
Yeah, that's good. Now that's a nice mix of an integer value and a fraction.
Right.
All right. So here you're still trying to divide by a fraction. So you're gonna turn it into multiplication by flipping over the fraction that's after your division symbol. Okay. I'm still gonna invert and make this multiply. 13 times 3 divided by 8. Wasn't sure what I was writing. That part makes sense.
Okay.
Now, this is a whole number times a fraction. I usually recommend make this look like a fraction so you recognize you're doing the numerators times numerators and the denominators times denominators. 39 over 8. And I don't see anything to simplify there.
Okay.
Okay? And
Thank you.
I'm going to do one similar to this, okay?
Okay.
Let's say I've got 5, 6 divided by 4. Here I got the fraction divided by a whole number. I'm going to do kind of what I did over here and say, well, let's think of this as 4 over 1 as a fraction. And now I'm going to turn it into multiplication. So it's always the number after the division symbol that you want to find the reciprocal of. Turn it over. And so what do I get here? 5/24. But dealing with your whole numbers or integers this way, you know, make them look like a fraction so they kind of match the format that you're working with. It's usually a good idea. All right. And so specifically in our text, we get to our text, which some of you, it's nice to hear somebody said they were actually looking at a text problem. Good for you. Practicing with problems out of the textbook. So in our division of fractions, they actually present these complex fractions, all right? Complex fractions. Because it's a division problem, right? It's a fraction and which represents a division problem. So now, just like I started, use this kind of example to describe how we divide. I'm just going to say, I'm going to write it out, but maybe you just recognize I'm just going to have to flip over the bottom number. So that means the same thing, right? 3/7 divided by 6/11. And so I'm going to turn that into 3/7 times 11 over 6. Looks like I can cancel some 3s. 11/14. How about one more of those, okay? And
Thank you for sharing that. Thank you for sharing, because I keep forgetting to flip it. And so I'm kind of liking them.
yeah, it's not gonna work if you don't.
No.
All right, so here's another one of those, and this time I just mixed in some variables, right? It's the same as, and you can, like I was saying, you can skip this if you're really comfortable with, I'm just gonna flip over the bottom, but I'm not gonna shortchange you here. This is the same as the top fraction divided by the bottom fraction. Whoops, 6 on this one, sorry. Okay, and so fraction divided by fraction, I'm going to turn it into multiplication. Flip this one over, 6 over xy. I'm going to look to cancel to simplify. 2's are probably pretty obvious for you, but here's an x on top and an x on bottom. I can cancel that too. I can divide by x. That just leaves one y. 1 times y, whatever that is. So you can cancel a variable between the numerator and the denominator also. So 1 times 3 is what was left, and now 1 times y, so 3 over y. If you see something like that, you can deal with the variables the same way. And, all right, so I'm pretty sure.
I didn't write that.
Oh, did I do that too fast, Erase?
Oh, sorry. I didn't know I was unmuted when I said that. Sorry.
Yeah, right. Careful what you. I think I left today to finish 1.5 and start 1.6, and on my schedule, revised schedule, I expect we're still going to do more ones, add and subtract tomorrow. So I'm not rushing to try to get through everything today. But here's one of those sort of order of operations kinds of problems that we run into in practice every section. This is a fraction because of the fraction bar. The fraction bar is a grouping symbol. And it really suggests that I should do as much as I can on top separately from everything I can do on the bottom. I kind of like this one before I go too far, just because Notice this is a minus sign. These are two separate terms. They're not factors, right? They're not things right next to each other multiplying. I can't say, well, it's almost too bad there's a 3 there, but I can say, oh, I can divide this by 3 and that by 3. Again, add and subtract. These are two terms. Unless it's multiply, 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 you can't cancel common factors. They're not factors yet. They're still terms to be added together. Don't try to cancel until it looks just like multiply. All right, so I'm going to approach this as simplify the top and then simplify the bottom. So 6 minus 15, and I can do a little on the bottom. Here's my exponent. All right, and simplifying here, 6 minus 15, negative 9. And this is 12. And how about I'll divide both those by 3s. And it was negative 3/4. The point there was to treat it like a grouping symbol and simplify numerator and denominator separately as much as you can. So, okay. I always kind of pause and wait for somebody to say, wait. Don't want to erase if you're still trying to copy. How about this? Everybody's favorite, I know, word problems or translating. Right now we're just working mostly with expressions. Can we come up with the algebraic expression for this phrase? Eventually when we're solving, we'll be trying to add those expressions as part of equations, put them together and then solve that equation. But here we go, the quotient. Oh, we're talking about division, right? The quotient of, oh, we're going to divide a couple things. Here they come. The difference, oh, we're subtracting, of A and B and C times D. Now, wait a minute, there's like a couple different things going on here, right? I put that comma in there on purpose, right? Sort of separate two different pieces or phrases, just like we would in English, really. So the quotient of, okay, I'm expecting to divide a couple things. I'm going to write as a fraction. The quotient of the difference of A and B. That's one part. That's one, and it's always the first number divided by the second number, so that first part is the numerator. It's always numerator on first piece, denominator is the second piece. The difference of A and B means I'm doing that for my top, the difference of A and B. And the denominator, so there I put the comma there so you know, okay, that was one piece and here's this other piece of the quotient. CD is on the bottom. Now, this can get messy if you don't get the help of a comma like that, but hopefully you won't run into problems where it's not clear which pieces should group together. And if you do, send me a message and well, I don't get it. Anytime, send me a message. So I just wanted to do an example like that where we had a translation problem. So quotient means divide. Difference meant, oh, there was a subtraction part. And then we were just given that other. I'm going to start add and subtract. 1.6. And abbreviate fractions. Okay. So what's the deal? I'm sure maybe you remember. Add and subtract. If I have half of something and I want to add it to 1/3 of something, apples and oranges, same size pieces. They don't turn into fifths. Fifths are actually smaller than this one started, right? It's half and 1/3. Fifth is a smaller piece. You need the same size pieces. common denominator. Before you can add or subtract fractions, you must be dealing with the same denominations, the same size pieces that you're combining. All right, so you're now ready to do that. That's the big deal. Everybody's favorite thing about adding and subtracting fractions. So sort of the generic, I always say, the theoretical, if I have a fraction with that denominator and I want to add it to a fraction with the same denominator, then how many of that size piece do I have? It's just the a plus b. You keep that same denominator and you combine the numerators. All right, 3/4 plus 5/4. I got a whole bunch of fourths. Oh, I made up 8. It just happened to turn into 2. Okay, that I just made it up. That's happened. That wasn't the point, right? Same denominators, add the numerators together. Same thing for subtraction. If I've got the same denominator, don't get sloppy. If I've got the same denominator, then I just keep that value in the as the denominator, the size of the pieces, and I do the operation in the numerators. You know, so 9/5 minus 2/5. I have a bunch of fifths, but I took away 2 of them. 9 minus 2 means I have 7 of them. Here we go. Oh, there was something like this. Maybe it was a text problem. Most of my examples are out of our textbook that I referred to here. Funny looking 9, but I have 3 fractions that I'm adding or subtracting. They all happen to be cut up into ninths, so I can combine them. This is equivalent to 2 plus -4 minus 7 all over 9. So let's see, now it's going to be ninths of something, but what I have 2 minus 4, -2, minus 7 more, -9. Again, that example just happened to reduce to a integer. But same denominator, so just work with the numerators, do the operations in the numerators.
Quick question.
Yep.
So if we get whole numbers that equal integers, we write it down as an integer, correct?
I would encourage you to think of that as a simpler form. Yes. Now, if mom marks it wrong, because they said, write your answer as a reduced fraction, and you, on the other hand, if you left it as a reduced fraction 4/1, I think that ought to be fine also, okay? If it's not sort of specific, whether it should stay as a fraction or stay as an integer, I'll give you credit either way. But yes,
Okay.
changing a value, simplifying a value to its integer value, I think is fine, is good. All right?
Thank you much.
Yep. And that is the thing, especially on your tests. When the test will look just like homework problems, same format. You know, do one minute, enter your answer and go on to the next. And I always go back and check them myself. That's why you don't see your grades immediately. And I check everything you got wrong in particular to see, did they, well, I look for partial credit if you got close, you might say, or their format was just not exactly what mom was looking for, but it was correct anyway. You know, I'll give you credit for that.
So what happens if you're adding 2 with 2 different denominators?
Well, that's the big next step here, okay?
Oh, okay.
Yes.
Sorry.
That's no problem. Here we go. So that's the more work, right? If it's the same denominator, I might call it easy, you know, but if they're not, then you gotta make them have the same denominator. abbreviate them. How do I make them? I'm going to build equivalent fractions for one or both of them. I'm going to change with the correct denominator with, and here we go, the lowest common denominator. Remember we did least common multiple? What's the smallest number bigger number they both fit into? Least common multiple when we were just dealing with the numbers. Now within a fraction, it's going to be the bottom of the fraction or the denominator. So I'm going to look for the least common denominator or lowest, smallest common denominator I can come up with for both those numbers. Otherwise, I'm dealing with really big numbers. So here's one. Well, how do we come up with the lowest common denominator, the least common multiple? We are going to look at the factors that each of those numbers is built out of and try to figure out what's the smallest number I can build out of these two. Now, if you get lucky, you might say, here's a prime number and here's a prime number. 1 times 5, 1 times 7. There's no like overlapping common factors in there. So the only common denominator, the smallest common denominator I can come up with, not the only, is I get by multiplying 5 times 7, right? 35, 5, this denominator times this denominator. You may know this. You can always get a common denominator by multiplying them together. What we're trying to avoid is two big numbers multiplied together getting this huge denominator. So we try to get the smallest one. But 5 times 7 will get us a number that is both divisible by 5 and 7. It's a equivalent fraction. 35 is a multiple of both of them. So I'm going to build two fractions now that are equivalent to what I started with. And they're both going to have a denominator of 35. The 5 times 7. Okay, squeeze that in over there. Well, how do I get from here to here? Equivalent fraction. You always have to multiply the same thing in the numerator and the denominator. Well, I had to multiply the 5 times the 7, so I have to multiply the numerator times the 7. That makes this one 21 over 35. Squeezing it in there a bit. Here, I had to multiply the 7 times a 5. So I have to multiply the 4 times the 5 and make it both proportionally equal, bigger equivalent fractions. That makes this one, what, 20. This is the basic process for getting the common denominator. Figure out what you're going to use, and then what did you have to multiply to turn the original one into that new denominator, and make sure you do it to the top and bottom. Now I have a common denominator, so I'm going to end up with a combined number of 35ths. 41. 41's a prime number. Done with that one. How am I doing time-wise? Good. So that was the basic process, and I started with a couple where there weren't many options for the common denominator. Two numbers that were prime numbers. Only way I'm going to get the common denominator is to just multiply them together. Well, what if they aren't prime numbers? What if they have some common factors? Here I go.
I have a question.
Okay.
So would that be the final number? Like the answer, the 41 over 35, even though the denominator is smaller than the numerator?
Oh, yes. We did mention this a little bit last time, but this is, you've heard the term improper, means it's more than one, right? The top is bigger than the bottom. That's fine, right? Don't try to make a mixed number out of it.
Okay.
Okay.
Perfect. Thank you.
There's no common factors. There's no simplifying to do it. If it's not lowest terms, you want to work on that. There's nothing about our addition and subtraction process that guarantees your this version, that answer is going to be in lowest terms. Like when we multiply, we would do some canceling first. But you kind of got to add and subtract and then look to see if you can simplify it. There's nothing about that process that makes it simple to begin with. All right, so let's say I want, here I have two fractions again, I'm gonna add. All this is totally the same, applicable to subtraction, but just, think of addition. Well, I wanna get a common denominator so I can combine those. Well, here's this process, right? 9 is 3 times 3. Well, 3 is just 1 times 3. So I need, long story short, 3 times 3 takes care of this 3, or obviously, I hope, 9 is a multiple of 3, so 9 will work as the common denominator. I'm only going to have to change one of the fractions and make it a fraction with a 9 for the denominator. That one I'm not going to have to change. How did I get from 3 to 9? I multiplied both of them by 3s. So if you get lucky, you might only have to change one, because the second one works as the common denominator. Added them together, 11's a prime number, nothing more to do, no simplifying. Just keep doing this, we'll keep going here. I did it in the same order, but do you recognize that 16 is a multiple of 4? I don't have to change, I can use the 16 as the common denominator, because I can easily, you might say, change 4 into 16. I can make an equivalent fraction. So I'm gonna, see, I always kind of set myself up at where I'm trying to go, especially when I'm teaching it. Like, okay, I'm not changing this one. How did I get from here to here? I multiplied by 4 over 4. This is equivalent to that one. Same size, 17. 17/16. Oh, got lucky again. Another prime number, nothing to cancel. All right, we're working up, you might say, more and more complicated, something like that. All right, 5/6 plus 11/15. Again, if I do 6 times 15, I get 90. I mean, I can make a common denominator just multiplying. That's kind of like the last resort. Is there a smaller number that I can use? I'm going to present this just like in earlier in the chapter, 2 different ways. How do I get this least common multiple or common denominator? Number 6, as it's break it down, what are all the prime factors? You can do the factor tree. And that's it, right? 6 is 2 times 3. Well, what's 15? 3 times 5. Get myself out of the way, right? I'm going to line them up like this. Well, I want to line up the 3s because it's a common 3. They both have that 3 in them, but I need a 5. So what are all the different factors I want? I need a 2 for the 6 to go in it. I only need 3 one time for either of the numbers. I only need one factor of 3, and I need a 5. So that number, 2 times 3 times 5 is 30. Oh yeah, let's both go into 30. That's the smallest number that they both divide into evenly, or that's the smallest multiple of both of them. Now that other technique, I always show this to see if I can get somebody to try it this way. The other technique is to just start going down your list. 1 times 15, 2 times 15, 3 times 15, 4 times 15. All right, 1 times 6, 2 times 6, 3 times 6, 4 times 6, 5 times 6. Oh, there is a common multiple. So you just keep multiplying until you find a number for both of them that's the same. Find that common multiple, least common multiple. All that was to say, all right, I'm going to turn these both into 30s. Now, what do I do to turn 6 into 30? I multiply it by 5. So 5 over 5. I'm multiplying both the numerator and denominator. I'm going to get this out of the way, okay, so it's not confusing. So that is equivalent to 25 over 30. How do I turn 15? By 2. Same thing on top. 22 over 30. Now I've got a bunch of 30s. 30 little pieces. 47. 47. No, I think it's a prime number. Certainly not divisible by 2 or 3 or 5. Okay, so we had an overlapping factor of 3. If I'd done the 6 times 15 and got to 90, that would have worked, but they'd have been really big numbers. By figuring out the least common multiple, I got something a little more manageable, the 30. At least that's what we claim, right? Sure, that was easier, wasn't it? Oh. 7/12 plus 11 over 30. One times 12, 2 times 12, 3 times 12, 4 times 12, 5 times 12, 6 times 12. Hopefully I don't have to go any farther. 1 times 30, 2 times 30, woo, 60. Okay, 60 is the first common multiple, the least common multiple. I'm going to turn these both into 60s. 12, I'm going to do this real quick the other way. 12 is 2 times 3, 2 times 2 is 4, right? 2 times 2 times 3. All right, 4 times 3 gets me my 12. 30 is 2 times 3 times 5. You can do the whole tree thing. But you see all the different factors to get there. I need a 2, but I need a second 2 if I'm going to divide it by 12. There's a common 3 and the 5. So there's how that system works. One of the 2s they shared, but there was an extra 2 to get me a number divisible by 12. I shared a 3, so I only needed the 3 one time. And then the 30 needed a 5. Multiply that and get us a 60. Okay. And okay, so what did I have to multiply 12 by to get to 60? It's 5. Actually, you can look over here and say, what was the extra factor that I had to multiply? 2, 2, 3. Oh, I had to multiply by the extra 5. That's what it was here. 35. This one's not too tough, right? Times 2. So 22. All right. A bunch of 60ths. 3, 4, 57. 60ths. I can reduce this one. You see it? What can I divide them both by?
3.
Yeah. 5 plus 7 is 12. Oh, 57 is divisible by 3. By 3. Well, yeah, it's 1 3 less than 60, isn't it? So 57 divided by 3 is 119. 3 times 20 would be the 60, right? 19/20. That one did take some reducing before we were all done.
Since we were able to reduce it, does that mean that 60 would not have been the least common denominator?
There was 60 still had to be the least common denominator for what we started with.
Okay, that makes sense.
Yeah, that's what I was trying to say. When there's nothing that guarantees this is going to be reduced when you're dealing with plus or minus, the two separate pieces. Until you put them together and we just happen to get a number on top that is similarly divisible.
Perfect, thank you.
Well, folks, you know, that's really going to get you through most of the add and subtract. And we'll get into some of the messier, you know, some complex fractions or anyway, we'll do more, right? We'll do more tomorrow. We'll pick up here, but we've gotten to our 10:50 time. So going to sign off here in a moment. Finish up your 1.3, 1.4. I'll be checking for questions you might have throughout the day. Okay, and then we'll carry on tomorrow. Finish up adding and subtracting. Oh, one comment. You may notice 1.7 is not assigned. It's a section on decimal values, you know. So we occasionally, maybe even in a word problem, we'll run into a decimal value, like if we're working with dollars and cents, that kind of thing. So understanding place value to be able to add and subtract or multiply decimals, something to maybe review a little on your own if you, and feel free to bring up a question if you have an issue with decimal value. But specifically, we're not going to cover that section. All right. Okay, folks. Well, see you in the morning then. Okay. Have a good day. Sun came out.
I had a question for you real quick when everybody signs off. I had a question for you.
Yeah,
Question? Yeah.
I also had the same thing.
All right. I'm here. No problem.
Thank you so much. Have a great day.
Thank you. You too. Yeah. Well, you're free to leave. But I'm here. Go ahead.
I just wanted to ask, I looked over the syllabus or my grades, and I noticed that I missed a discussion forum the first week or the second, the first week of class.
Uh-huh.
Any way that you could open that up for me so I could get that 10 points, or is it?
You know what? Just to get you guys to participate and interact, I made it worth something, 5%. To ask you to post once or twice during the week. Nobody's going to fail this class because they are short on a discussion. Okay.
Okay.
I'm going to ask you to, just start with week 2 and join in. And if we get to the end of the term and 1 week's discussion has made a difference, I wouldn't worry about it.
Thank you, Professor. Have a great day. Thank you.
Good. You too. See you later.
All right.
Other questions someone there had?
I had a question on one of the hand-in homework questions.
Okay, sure.
And a homework question that was, that was in 1.4.
Oh, all right, sure.
Okay, so it was in the 1.4 homework, and I was having a hell of a time.
Yeah.
The equation was 4 squared minus b squared minus 4ac.
Oh, this one, yes. Okay. This is an important piece, algebraic shape, for more advanced equations that you would get to, say, in the next level class. I think anyway.
Okay.
So it's an evaluation question. You're going to plug a number in for each of those numbers, right? Yeah, what do they want? What numbers did they give you for B and?
I don't remember off the top of my head. I believe B was -3, A was 2, and C was,
Let's just make up.
I think it was 6.
How's that? Does that work?
Yeah, it looked like
The
that.
handout thing, the handout homework
Well, I think
No, this was in homework.
in the
What is it,
actual.
1.4?
this was out of 1.4, an evaluation problem where we're multiplying integers together. And I'm guessing this is the one where you got to be careful. B is a negative number, and you're going to square that negative number. That really means when you substitute it in, it needs parentheses to say the whole thing gets squared. So that means -3 times -3. Technically, if you write this, that means the opposite of 3 squared. That's -9. But this is going to be +9. But finishing this up, 4 times 2 times, let's make this negative just to make it messy, okay? How's that? Is that all right? I changed that. All right. But
How do we know when it's parentheses negative? How do we know when it's positive if it doesn't exactly show?
okay. Now, here this is, I always have to go make sure I cover all the explanation here. B, whatever value B is going to get squared. All right, it's going to be B times B. B happens to be a negative number. So it's going to be this negative number times this negative number. -3 times -3. Negative times negative turns positive. So that's how it's going to become positive. Now, when writing it out, what I just said, -3 times -3, or you have to put it in the parentheses to notate that, for you to show that, and for we all understand what you're saying. So this is how you say the -3 times the -3. If you meant the opposite of b squared, you'd say, you'd write this, and this means 3 times 3, and then whatever you get, you make it negative. So
That makes more sense.
these are two distinct, very important differences, and I know I keep trying to drill it in there, you know. Okay, so this is a 9 minus, so let's say 8 times -5, and that's a -40. And so now I have minus a minus is really, squeeze it in, 9 plus 40, 49. You follow that?
Okay, yeah, that makes a lot more sense because it's been a long time since I've done any of this, so it's all kind of a blur.
Join the crowd. Yes.
I agree. I agree.
Yeah. Well, oh gosh, I keep trying to, I understand all that, right? That's why I have this job here. You guys are taking, pardon me, but like kind of like reviewing high school math before you can do the rest of your college program, right?
Yeah.
And so that's what we're doing. Okay, other questions?
Okay.
Another one. Oh, you had one from the handed homework.
Yes, I actually did. Let me reach over here and find it real quick. It was a it was question number 4.
All right, remind me.
It was simplify. It's 6 squared minus 4 squared over 4 minus 6.
Okay. This is, you might say almost like why I said I'm going to postpone this until later in the week, because this is a fraction that you need to simplify. And the fraction bar is like a grouping symbol, so you need to do the top separate and the bottom separate. Okay?
Right. That's what I did, but I wasn't sure about it.
So within the top, square the 6.
36
Square the 4.
and 16.
And here on the bottom, 4 minus 6.
-2.
So far, so good.
Right.
On the top, 36 minus 16.
Fine.
Now, do we need to reduce that even further?
20
Okay.
divided by 2.
10.
It's 10.
And positive divided by negative, -10.
Negative. Okay.
Okay.
Yep.
Yeah, that's what I had got. I was just making sure that I'd done it correctly.
Yeah, I know. It's easy to second guess and overthink. And is that what?
Exactly.
I'm thinking of one that's also on the hand-in homework. I think very similar. What if I just made up something that looks like that? There's something similar to that, I think, on the hand-in homework. It's kind of like the b squared minus 4ac thing you just asked me about. Square the x, but x is negative. I don't know what numbers they told you to use, but it's something similar.
It was a +7 and +10.
Yep.
That's what the numbers were given, but
You can follow
it doesn't matter.
and see if you can apply it, right?
Exactly.
So see how because whatever x is, I'm going to square it, but x was negative, so I use the parentheses again. That's what I'm trying to think about. So this is -2.
Right.
-2 is +4 minus 16. That'd be a -12.
Okay.
Yeah. So this one I was squaring, but I'm gonna take the opposite or subtract the square. It was a positive number, so it's just 4 times 4. I didn't need parentheses on that
Right.
one. Okay.
I think that wraps up my questions. Thank you very much for your time.
Thank you.
No problem, Great Hunter. It's good to have you ask questions. All right. How about you, Gideon? Questions? You're good. All right.
No, I just wanted to hear what he said because I was probably in the same boat.
All right. We'll see you guys tomorrow.
All right, bye.
All right. Thanks.
Mhm.
Bye.
You're welcome.